Okay guys, here we go. Today's objective is for you to be able to write equations of parallel and perpendicular lines given a point and an equation of a different line. So really making you do a lot of thinking here, a lot of application. First, I'd like to point out that the parallel, this is the symbol for parallel. So if you see this, it says parallel. This is the symbol for perpendicular. So when you see this upside down T, that's the symbol for perpendicular. Let me tell you this. It's all about the slope. Parallel and perpendicular is all about the slope. So if you can identify the slope when you're looking at an equation and you know what parallel and perpendicular slopes are, and I'm going to tell you it's easy. This isn't any harder than what we were doing when we were writing equations for the assignment the other day, and you're better at it now, so it's going to be fast. You guys are going to be so great on your ACTs and your SATs, I promise. Okay, make sure you've got your objective written down. Make sure you feel comfortable that you are able to write equations of parallel and perpendicular lines if I give you a point and an equation of a different line. Okay? Make sure you're comfortable. And anything you don't understand, have a question written down in your notes. All right, fast forward through certain things. If you're able to get through a certain page you can read the instructions and do it. You can fast forward to the end of this page, and if your math matches my math, then you can skip to the next page, okay? If your math doesn't match my math, maybe you need to go back and watch what I did and make some corrections. All right, here we go. So, first kind of problem that you might see is one of these. First of all, make sure you write this down. Parallel lines have the same slope. Now, that does not mean that they look the same. Sometimes you might see a slope, you'll do some math, and you might see a slope that looks like this has a slope of 2/3, and another one has a slope of maybe 4/6. But to be honest, if I have a slope of 2/3, so let's say I've got my x-intercept here and it's a rise of 2 and a run of 3 and a rise of 2 and a run of 3, it's the same as a rise of 4 and a run of 6. Okay, so even if they don't look the same, if they reduce down to the same number, they're parallel. Okay, so it says write the equation of a line that passes through a point, and you know you've got to have a point if you're going to write the equation of a line, and is parallel to this line, and write it in standard form and graph the line. Okay, so we know that parallel lines have the same slope, and we have our equation here in standard form, but that doesn't show us the slope. But if we just really quickly convert it to slope-intercept so we can see it, we'll be in good shape. So let's put it in slope-intercept form by taking the 2x, subtracting it from that side, and putting it right up front right here. And we get negative y is equal to negative 2x, and push that positive 10 out to the end of the problem. Okay, and it's almost in slope-intercept form except for this negative, so let's divide the -1 off of the whole thing, and we have our slope-intercept form. Negative 2 divided by -1 is 2x, and negative 10. So this is this line. So let's graph it really quick just to get some practice. So this line here looks like this. Our y-intercept is 0, -10, so we're going to go down 10 spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's that point, and it has a slope of 2/1. So we rise 2 and run 1, and rise 2 and run 1, and do it enough times that you'll get your intercepts for both your x and y axis. And let's graph that line. Let's graph it in blue here. Okay, and make sure we get it nice and organized. Okay, so that was our original line. That's the line, that's the graph of this line here. All right, so now we're going to write the equation of this line, the line that passes through this line, but let's use the slope we found. Our slope that we found in this one was 2, so our slope is 2. So we have a point. Sadly, guys, this point is not in slope it's not our y-intercept, it's just a point. So we've got to plug it into point slope. So we're going to plug it into point slope by plugging in our -3 for our y sub 1, and our slope is 2, x minus 1. Let me do a little squiggly there. All right, so there's our point slope. We've got a double negative to manage and some distribution. So we got y plus 3 equals 2x minus 2. And we've got to write it in standard form. But let's put it in slope-intercept so we can graph it real quick. So we'll move the 3 over here. It's got to go over there for standard form anyways. And that gives us y equals 2x minus 5. It's ready for us to graph now. So let's do our graphing. Our y-intercept is -5, 0, -5. And our slope is rise 2, run 1. Because remember, it's 2 over 1. Rise 2, run 1, rise 2, run 1. I've intercepted my x and y axis, so that's enough for us to see. And look at those perfect parallel lines because their slopes were the same. All right, so now all we got to do is make sure we write it in standard form. So all we got to do now is move the 2x over. So we're going to subtract the 2x and put it up front. That gives us -2x. Positive y equals -5. And you know that we don't like our leading coefficient to be negative. So we're going to multiply everything times a -1, and that gives us 2x minus y equals 5. And this was one of our tasks, was to write the equation in standard form, and the second one was to graph the line. And so this is the line 2x minus y equals 5. And this is the line 2x minus y equals 10. Those are our two lines that are parallel. Okay? Very, very comprehensive lesson right there. The next one will be a little bit simpler, okay? So let's try this one. Write the equation of a line that passes through -2, 4, so there's our point, and is parallel to the y equals 1/3 x plus 2 in slope-intercept form and graph. Well, we're a little luckier this time because we were given our equation in slope-intercept, and so we have the slope already. So our slope is 1/3. Now we have to graph both lines. So let's go graph this one really fast. Our y-intercept is 0, 2. So that's where it's going to cross the y. It's got a rise of 1 and a run of 3. So from that point, we rise 1, run 3. Let's go the opposite direction so we can cross our x-axis. Down 1, left 3, down 1, left 3. There's our x-intercept. So here's our slope, or our line, for our original graph, our original line. Now let's write our equation for this one. So let's plug it in, our point slope. Because again, we don't have the y-intercept because this is not a 0. So we've got to plug it in point slope. Y minus 4 is 1/3 of x minus -2. Double negative change. So we'll distribute y minus 4 equals 1/3 x plus 2/3, because 1 times 2 is 2 over 3. There we go. So now we got to do is put it in slope-intercept by moving the 4 over here. So y equals 1/3 x. We're going to have common denominators here, so we're going to multiply times 3. That gives us 12/3. So we have 14/3. Now, this is our y-intercept, and I got to tell you that that's probably not going to be real easy for you to figure out. So probably better be changing it to a mixed number. So 3 goes into 14 4 times with 2 left over. So we have 4 and 2/3 would be our intercept. So it's 0 and 4 and 2/3, which is 14/3. So we're going to start with our intercept. That's our starting point. So we're going to go up 4, 1, 2, 3, 4. And then we're just going to split this space between 4 and 5 into thirds. So we're going to divide it into 3 sections, 1, 2, 3. So there is 2/3 about right there. Now we've got to be careful with our, you can do this, not a problem. We're going to rise 1 whole unit. So that means we have to go from 4 2/3 up to 5 2/3 because 4 2/3 plus 1 is 5 2/3. So we've got to go up to this point and run 3. 1, 2, 3. Rise up to another 6 2/3 and 1, 2, 3. And we can go down the other direction, down to this 2/3 and 1, 2, 3, and down, and 1, 2, 3, and down, 1, 2, 3, and we're going to be off the graph. But that's all right. It still gives us a really good indication of there's beautiful parallel lines, and they're written in slope-intercept. And this is totally fine written in this way. But again, you might want to, when you get fraction answers, you might want to make sure that you write it as a mixed number. Oops, that is not an eraser. As a mixed number so that you can graph it in the right spot. Okay? All right, so that's parallel lines, and that's writing it in either slope-intercept or standard. So good job. Let's move on to perpendicular lines. Perpendicular lines are lines that have opposite reciprocal slopes. It's really important that you pay attention to this part and this part of the terminology for perpendicular. Perpendicular slopes always will multiply to equal a -1. So like, for example, if I give you a slope of 3, that's +3. Its opposite is going to be a negative. So the signs have to be opposite. That's the opposite part. And the reciprocal part is that you have to flip the number over. So 3 over 1, your rise over run has to switch to 1 over 3. And if you look at that multiplication, 3 times -1 is -3. 1 times 3 is 3. -3 divided by 3 is -1. So you can always double check to make sure your slopes are perpendicular by multiplying them and making sure you get a -1. That's opposite reciprocal math right there. Pardon that. Okay. All right. So let's take a look at these two. And let's practice. And I'm going to prove this, and it's going to take a little bit of time. All right, so perpendicular to this slope, opposite of negative would be positive, and flip it over 3/2. Okay, let's do the opposite reciprocal or perpendicular slope of 5. So opposite of positive is negative. Flipping 5 over 1 over to 1/5. Okay, so what I'm going to do is I'll do it in 2 different colors, and I'm going to use my protractor to help us prove it. Okay, so let's start with this point right here, and let's see if these two slopes are perpendicular. Let's prove it with a visual. I need you to remember this part. All right, so if this was the point that I was given and it had a slope of -2/3, that means I would go down 2, because that's negative, and right 3. And it would be a negative slope, see, because it's dropping. Or you could go up 2, which is positive, and left 3, which is negative. And so this would be the line that you would graph. And we'll graph this one. This set will be graphed in blue. And I'm going to extend it out quite a ways so that we can prove with the protractor. Now let's go back to this middle point and let's graph this slope. So from this point you have a rise of 3 and a run of 2. And we'll go the opposite direction. A fall of 3 and a run backwards of 2. So -3 and -2, which is still positive if you negative divided by negative. So let's do this one in blue as well, and watch how these are perpendicular. So I'm going to put the center of my protractor on their intersection, and I'm just going to turn it until my bottom line is at 0. And there you can see it's a 90-degree angle right there. Okay, so we'll do one more. to show that that wasn't a fluke, that this actually is the truth. And we'll do it in a separate color. So we'll change the color of our lines to purple. All right, so let's choose another point. So let's say we choose this point right here. And we graph a positive slope of rise 5. 1, 2, 3, 4, 5. And right 1. Down 5. 1, 2, 3, 4, 5. And left 1. If it's going to let me graph that right there. All right, and going back to this, let's do a -1. So a rise of -1 and a run of 5. Or a rise of and a rise of 1 and go left 5, 2, 3, 4. 1, 2, 3, 4, 5. All right. So we're going to go with purple lines this time. So we're going to graph this point, this line here. Get it just perfect. And we're going to graph this one here. Just so. Ooh, that's not perfect. Let's get it perfect. And again, we're going to, let's see if I can grab it here. There we go. I'm going to line that up on the vertex or their intersection and just turn it a little bit. Get it on 0. And again, you can see they're intersecting at 90 degrees. So perpendiculars, opposite. One's positive, one's negative, and reciprocal. They're flipped fractions. Okay? All right. So now that we know that, this isn't that big of a deal. It's not anything different. We just find the slope and we flip it. Okay, so here's the point that I'm given. Write an equation of a line that passes through 1, 1. So there's our point. Perpendicular to y equals 3/4 x plus 1. Well, look, it's already in slope-intercept form, so my slope is here. So let's do perpendicular to this. So the perpendicular would be from positive to negative, and we're going to flip it, okay? Let's go ahead and graph this one really quick, and then we'll do all this work. Write the equation and graph it. So our y-intercept here is 0, up 1, and our slope is rise 3, run 4. Or we're going to go down 3 and left 4. 1, 2, 3, left 4. We'll get that one fixed up. We'll do it in purple here. And here's our original line, because we have to graph both. Okay, so there's our original, and that's practice graphing. Now, we have our slope, and we have a point, and it's not the y-intercept, so we have to plug it into point slope. -4/3 x minus 1. So we'll distribute y minus 1 equals -4/3 x plus 4/3. So now we just need to move this over to the other side to put it in slope-intercept form, because that's what we were asked for. So we're going to add 1. So y equals -4/3 x. And then we're going to add this. We're going to have to multiply it times 3 to get common denominators. So it'll be 3/3. So that gives us 7/3, which to find our y-intercept, again, we need to do 3 into 7, which is 2, and 1/3. So our y-intercept is 0, 2, and 1/3, and our slope is -4/3. So we're going to go up 2. And we're going to separate, we're going to split this into thirds. So there's 1/3, 2/3, 3/3. So 2 and 1/3. And we're going to fall 4 because it's a negative slope. So from here, we're going to go down to this and this and this and this and write 3, 1, 2, 3. So again, we're going from 1/3, 2 and 1/3 to 1 and 1/3 to 1/3 to -2/3 to -1 and 2/3, right? 4, and we'll go up as well. So we'll go up to 1/3 is 1/3, a third, 1/3, and left 1, 2, 3. And we're going to graph that line. through those. Ooh, that is not a line. Huh, sorry about that. Want to get a good straight line here. Okay. And there we have it. We can pull out the protractor really fast to make sure we did a good job putting our center at the vertex, giving it a little spin. And there you see it. A little bit off. There it is at 90 degrees. So you can see they're perpendicular. So you've answered the question. You're getting practice graphing lines. And there's your equation in slope intercept. So you've answered the question. And that's all I have. So ta-da, or voila, you can do this. It's going to be fine. Make sure you have questions and you can reproduce what we've learned today. Have a good afternoon. Bye.